So the final part of chapter 5 is abbreviated, and it's abbreviated in a really good way because as you can remember with fractions, when you had to add and subtract fractions, we had to have common denominators. And so we are going to stop in chapter 5 with 5.3 with rational expressions that already have common denominators. So that's what it means, adding and subtracting like rational expressions. And so they're alike in that they have common denominators. So there's no need to make them, which makes this section of chapter 5 a lot quicker and easier. So with this one, with the example that is arithmetic, when they have the same number down below, what we did was add the numerators and keep the denominator the same. It's as easy as that. There's a lot of space on this page. It's not really required. One thing to remember is the third step here. Always make sure that you've simplified your answer or reduced it to lowest terms. So for A, they have common denominator of 15. So I would write it out as 2x plus x all over 15. And I could simplify that to 3x over 15 because they are like terms. I can add x's together, but I should simplify this. It's not fully reduced as a rational expression. So my final answer would be x over 5. All of these have like terms, so they're quite straightforward that way. In this one, showing your work, you'd have 9b plus 7b as the numerators, and it's over the common denominator of a squared. So adding those numerators together, we get 16b all over 2a. And I'm done. There's nothing more I can do. I don't have common bases here, so there's no way I can simplify this any further. Two more on the page. B, we'd have 3 plus 5 all over that common denominator of x. So a final answer of 8 over x. Isn't this delightfully simple after all of that cancelitis stuff that we had? For D, I have the common denominator of 2ab, and I have 7. Ooh, I shook it up. This is actually subtraction, so we would subtract the denominators. That would give me a 2 all over 2ab. And this is not reduced. It's not a simplified rational expression. And so I could further simplify it as 1 over ab. Right? The top gets divided by 2 and the bottom gets divided by 2. So the binomials and more on the next page, those are just monomials as rational expressions. Here, not a lot different. We want to add the numerator and keep the denominator the same. So my final answer, 7 over x plus 3. Nothing more to do in simplifying that. For D, this is a bit of a whopper. So in D, I have common denominators. And so I would have 3x minus 5 subtracting 2x minus 4. This is key. Do you remember when we had these way back in chapter 3? We have to distribute that negative sign. I'm getting ahead of myself because I should just rewrite it over my common denominator. So doing a little bit of work on this, I'd have 3x minus 5 minus 2x plus 4. Still over my common denominator. Cleaning up my like terms, I'd have an x minus 1 on the top. The bottom, I could factor that trinomial. I'd have a number puzzle to deal with. It's an AC test. So -2, I could have 1 and 2 as a way to factor. It's going to be a -1 and a +2. This one is shortcuttable. And so I could rewrite it as x minus 1 and x plus 2. Now that it's all factored, I can cross things out, giving me my final answer as 1 over x plus 2. So kind of rolling in everything we've done so far with this adding and subtracting this time. And you can imagine, because they have common denominators, it makes this way simpler. So a few more to do on the page here. Maybe I'll throw the answers up and you can give them a try. Such satisfying answers on these ones. Give you some time to work on those. and then I'll show all my steps in the video. So these ones have common denominators, so I write the numerators, either adding or subtracting, over that common denominator. I want to make sure that my rational expression is reduced in simplest terms. So in order to do that, I need to see it in factored form. So I'd factor the top of my rational expression and write it over the denominator. So here I can see where those cancel out, and I'm left with my 4. For e, I'd have 2x plus 7y, and I'm subtracting. Remember, that's a binomial, so keep them together because we have the case like we had before. We have that distribution of that negative sign. This is all over my common denominator. Just rewrite it the same. And doing the work on the numerator here, I'd have negative x and negative 4y all over my x plus 3y. Gathering up my like terms, making that top, my numerator, a little bit easier to see, I'd have an x plus 3y all over x plus 3y, which is why I get the answer of 1. The last one on the page here, last one in chapter 5. I've got the common denominator of 2x. I'd have the 3x plus y subtracting the x minus 3y. So again, this distribution of that negative sign. And gathering my like terms on the top, I'd have a 2x plus 4y all over my 2x. Simplifying this, I'd take a common factor out of the top. So a 2 is common to those two terms, and taking that out, I'd be left with an x plus 2y all over 2x. And here it's just the 2's that cancel, bringing me to my final answer of x plus 2y all over x.